What's up, guys? Today we're doing a video on z-scores. Z-score is a measure of how many standard deviations above or below the mean a data point is. In other words, it's basically just saying how many standard deviations are you from the mean. So if I have the mean here, and if I've got a data point that's one standard deviation above the mean, we would say it has a z-score of 1. Or if it was -2, if it was 2 standard deviations below the mean, you would say it has a z-score of -2. Where it gets interesting is when you start talking about z-scores, which are decimals, they're in between. So if you had a data point which was 1/2 of a standard deviation above the mean, okay? So for example, maybe we're talking about test scores, and let's say average was 80, and it was a 5-point standard deviation. So every standard deviation is another 5, right? And you can make up some numbers and figure out what the z-score is. So for example, if you made an 85, then you have a z-score of 1. If you made a 90, you've got a z-score of 2. If you have, if your score was 82.5, if you were right here in the middle at 82.5, that would be 1/2 of a standard deviation. So you'd be 1/2 of a standard deviation above the mean. So your z-score would actually be 0.5 in that case. The formula for it is this. The z-score is your data point minus the mean divided by sigma, the standard deviation. So as you can see, if, for example, let's say you had an 85 on a test, that'd be 85, okay, minus the mean, which is 80. Well, what's the difference? It's 5, right? Divided by the standard deviation, which in this case is 5. So as you can see, you get 5 over 5, which is 1. Of course, we know that's going to be the case because this is right on 1 standard deviation above the mean. The other example I said, maybe you have 82.5 minus 80. Divide that by 5. Well, that's going to give you 2.5 divided by 5, which is 0.5. So as you can see, when you divide, you find the difference of your data point and the mean to find out how far away from it you are, and then divide by the standard deviation. And what you're finding is how many standard deviations you are from the mean, and it can be a decimal or it can be a fraction. Here's another example. It just says calculate the z-score, and they just kind of give you the parameters. You've got a data point 3.2, the mean is 2, and the standard deviation is 1. So all we have to do to find the z-score is take the data point 3.2, subtract the mean, which already you can tell we're 1.2 units, whatever the units are that we're measuring in, above the mean, divided by a 1. That gives us 1.2 over 1, which means you have a z-score of 1.2. All right, so this is what's called the z-score table. And what the z-score table does is it lets you look up any z-score. In the column here, you have, when you pick a row, you're picking the 10th place. And when you pick a column, you're picking the 100th place. So for example, if I wanted 0.53, I would go to the 0.5 row and go over to the 0.03 column. So this right here, see the 0.03, 0.5, so this is 0.53 right here, okay? And once you find that, what you're seeing, this number represents the percentage of data that would be in a normal distribution from the left up to that point. So for example, at 0, 0, this is a z-score of 0, 0, meaning it's 0 standard deviations from the mean, which means this is on the mean, okay? Well, on the mean, what percentage of the data should you find to the left of it? If you're talking about in a normal distribution, 50% should be to the left, 50% should be to the right. This is how much you find to the left, okay? As you go to the right, notice this number is increasing very slowly. So what's happening is as you go to the right in the normal curve, you're getting more and more of the data included in that from that point to the left. So 1 standard deviation, for example, right here, 1.00, okay? This is how much data you would find from 1 standard deviation above the mean all the way to the left. Okay, so that means, think about it now, the mean is above 50% of the data. And that next little box on our empirical rule table, on our empirical rule chart, that next box from the mean up to 1 standard deviation was 34%. So if you do 50% plus 34%, you can see this is 84%. Now it's a little bit off. It's 84.13%. but the empirical rule is kind of an approximation. This is the more exact number. Okay, 2 standard deviations. This 97%. This is 50% up to the mean, plus the next 34%, plus 13.5%. If you add that all up, you get about 97%, which is what this is. Okay. So anytime you get a z-score, you look it up on here, and this tells you how much of the data on the normal curve would be to the left or below that point. The other side has the negatives on it, and these just represent the points that are to the left of the mean. So negative 1.00, which is over here, this is 1 standard deviation to the left of the mean. In other words, if you take that 50% in the middle, you subtract 34% to go to the left. This is about 16%, which is what this is, 15.87. Okay. Okay, so here I have an example. It says, find the probability that x is less than 72 if the mean is 50 and the standard deviation is 10. So you don't really need to do this normally, but I want to kind of do a sketch just to make sure we understand what we're talking about here. Since I was kind of pointing at that chart and talking for a while, I kind of want to make sure we're very clear about what's going on here. So if the mean is at 50, the standard deviation is 10. So this would be 60, this would be 70, and then somewhere over here you'd have the third, which would be 80. Okay. Then a data value of 72, where would that fall? This is 1 standard deviation. This is 2 standard deviations. It would be right here. It would be just a little bit above 2 standard deviations. So it should be about 2 point something standard deviations. Well, first we got to figure out exactly how many standard deviations it is. We got to find the z-score. Okay, the z-score is going to be the data point 72 minus the mean, which is 50, divided by the standard deviation, which is 10. That's 22 over 10, which is 2.2. Okay. So what I have to do now is I've got to go to my table, and I can't exactly pull it up right now, but I'm going to look at my table. You should look at your handout that you have, your table. Find the z-score of 2.2 and see what the number is that it tells you. Okay, so my z-score tells me, for my table, it tells me 0.9861. What this means is that 98.61% of the data is going to be found to the left of that point. Now that makes sense if you look at the curve. We're right over here. When we say to the left, that means from here all the way over to here is 98.61%. Remember, this is 50% right here, plus 34, plus 13.5. So just to get up to here is about 97%. And that little bit extra makes it 0.9861. So if I were to shade this in, everything up to here, up to this point from the left, is 98.61%. All right, here's another example where I kept the mean the same, I kept the standard deviation the same, just to make it easy to talk about. But the trick, the difference here is that instead of being less than 72, I want to know what's the probability of something being greater than or equal to something, to 46 in this case. So again, if I do a little sketch, and this doesn't have to look pretty, but if I do a little sketch of a normal distribution, the mean in this case, again, is 50, 60, so on. We really need to be concerned more with the left because this is where we're going to be 40, 30. Our data point 46 is somewhere a little bit above halfway between these two. Okay. Now just thinking about our probabilities, this is 50%. There's 34% here, so everything up to this point should be about 16%. Everything from here up should be about 16%. So I need to add, so somewhere in between 16 and 50% is going to be my answer, right? It's got to be a little less than 50% because it's 50% from here. So somewhere between 16 and 50% is everything up to this point. But remember that now they want to know what's greater than 46. What percent of the data is greater than 46? So that means we're looking from this point up to the right. Okay. Now the trick to doing this is to first figure out what percent of the data is found up to this point. And since everything has to add up to 100%, if I know how much is to the left of this point, I can subtract that from 100% to figure out how much is above that point. Okay. So what I really want to do is find the probability of being less than 46. Once I've got that probability, I'm just going to subtract it from 1, which represents 100%. So first, let's find the z-score. It's going to be 46 minus the mean, which is 50. So of course you can see it's going to be negative, which it should be because it's to the left of the mean, divided by 10. That's going to be negative 4 over 10, which is negative 0.4. Okay, now I'm going to look up in the table to find the probability that something would be left of that, 0.3446. So what that means is from here to the left represents 0.3446 or 34.46% of the data, okay? But I don't want to know this part. I want to know from this part all the way to the right. And since everything has to add up to 100%, what I'm going to do is I'm going to do 1 minus 0.3446. Okay, you can just type it right in your calculator. 1 minus 0.3446 and press enter. That's 0.6554, or about 65.54%. And that's the amount of data that would be to the right of this point. Okay, one last example. The probability is a little more complicated here. Instead of saying everything to the left of a point or everything to the right of a point, I'm saying I want everything in between 2 points. What's the probability that something in this distribution would be between 32 and 59? Again, I kept the mean the same and the standard deviation the same just to keep it simple. If I do a sketch, here's our mean of 50 again. Okay, it's going to go up to, we'll have 60 here. This will be 40. This will be 30. That's far enough. So from 32, which is somewhere around here, up to 59, which is somewhere around here. Okay, so what I'm looking for really is everything in between these two. I kind of want to find all of this right here. Okay. Now remember, the only thing the table can tell you is how much data is to the left of a point. So if I know how much data is to the left of this point, in other words, I can find this, and then separately I can find out how much data is to the left of this point, which means I can find all of this. How can I use these two to find this amount? Imagine if you had this cut out. If I were to actually physically cut this part out, how could I take this and get this? I could go back with this and cut this part out. Okay, so if I were to take this probability, subtract from it this probability. So if I were to just take that part off, then that would tell me what this part is. So we're going to find the probability of the bigger number minus the probability of the smaller number, and that's going to leave the part in the middle that we want. All right, so we'll do that. One of the z-scores is going to be, I'll start with the left, 32 minus 50 over 10. That's negative 18 over 50, over 10, which is negative 1.8. The other z-score, we call them z1 and z2 if we want to. The other z-score is going to be 59 minus 50 divided by 10, which is 9 over 10, which is 0.9. So I'm going to look up on my z-score table. I'm going to find the probability for being less than 0.9 and the probability of being less than negative 1.8, and I'm going to subtract the bigger number from the smaller number. So let's look up those two numbers now. Okay, the larger number is 0.8159, and I'm going to subtract from that the probability for this number. .0359. And so when I subtract these, 0.8159 minus 0.0359, I get 0.78. So that means 78% of the data is going to be in between these two values. That's our answer.